Good afternoon, everyone, and thank you for kind introduction. And I'm Woo Kim, and I'm doing PhD in NTU. Today, I will talk about electrochromic alarm system for smart contact lens. Before starting my presentation, let's watch the video clip of Mission Impossible 4.
Marriage to fancy. Searching. I'll take it from here.
Sorry for interrupting. I know you want to watch more, but is there anyone who used this smart contact lens in real life? The answer will be no. It is hard to realize this perfect smart contact lens in real life, but many researchers working on the component of smart contact lens. So first, I will introduce the recent research for smart contact lens, and I introduce the electrochromic alarm system. Lastly, in conclusion. So many researchers working on the sensor of smart contact lens. In here, there is a glucose. So a research group in UNIS succeeded in detection of the glucose for checking diabetes using the wireless communication and wireless power supply. And research group in Post-Tech in Korea succeed in drug delivery, and they integrated ASIC chip for RF communication. Also, battery is important for giving the power to this sensor and actuator. Lithium-ion battery was integrated into smart contact lens. In previous research, they used the transmitting coil for giving the power and getting out the data from the sensor. But this wireless communication require high power consumption, and if we don't have this transmitting coil, we cannot get the data. So in here, we suggest direct information transfer to user by color change. So I will introduce electrochromic alarm system. In normal situation, the color of contact lens remain transparent. If the sensor detects some problem in user's body or detects some dangers around the user, then color of contact lens became blue. So user know that there is a color change and react accordingly, like taking medicine or going hospital or escaping that place. So this electrochromic alarm system consists of two electrodes. One is located in this center and the other surround the center electrode. So for this color change, electrochromic material was used. You can see this smart window in real life. So if we apply this color change to contact lens, we can give the direct signal to the user. So in here we use the Prussian blue material because it shows the color change between transparent and blue. And also it is very cheap material that it can even be used for dyeing material of jeans, and it is safe because FDA approved this material to special medicine. On the surface of contact lens, there is a tear, and inside of tear there is a sodium and potassium ion. Using this sodium and potassium ion, for example, have chemical reaction. So if this ion inserted into this structure, which is reduction, the color becomes transparent. And if this ion came out from this structure, which is oxidation, color become blue. So as shown in video, if we apply the voltage between these two electrodes, we can see the clear color change. And we got the RGB data for checking the performance of color change from the video. And we use a MATLAB, and we selected pre-selected area for getting RGB data. And as shown in this graph, red value changed more than green and blue value. So we use the red value for representing this color change. And when the color of contact lens is become transparent, red value show the higher value, and when it's blue, if the contact lens color is blue, then red value is low. And we compare the red value change and transmittance, and they show the similar trend. So in here, we use the red value for representing this color change instead of transmittance. And in order to check how users feel with this contact lens, we put this contact lens on the surface, on top of cell phone camera, and we took a video through the contact lens. As shown in this video, we can see the clear color change, and we can see this object even blue state. And also we demonstrated Morse code pattern using this color change. Morse code pattern is expressed by this dot and dash, and letters made by combination of this dot and dash. And we express dot using the 30-second color change, and dash is expressed by 6-second color change. And in here, we expressed university name, NTU, and the name of symptom, TIA. So also for giving the direction to the user, left is expressed by Morse code L, right is expressed by Morse code R. So after integration of vital sensor, complex and diverse signal will be transferred to the user. If we use the smartphone for detecting this color change, we can do self-diagnosis using cell phone in any time and anywhere. So for that function, we use the computer vision for detecting position of color change and amount of color change. Computer vision is scientific field dealing with images and videos. So it is normally used for detecting the road and objects for self-driving car, and also it is used for facial recognition. And researchers use it real-time pattern recognition for electrochromic micro display with temperature sensing. So if we can use this computer vision with electrochromic contact lens, we can do direct signal transfer to the user and with detecting the position and amount of color change. Previously, we used the material for detecting pre-selected area, but we cannot use it with the moving object or in real-time application. So we use a Python and OpenCV. So we draw the grid like this, and we take some point which show the clear color change, and using this point, we calculate the center and radius, and we draw the circle on the video. So as shown in this video, we can see the symptom 1 appear only when there is a color change, and we get a red value graph in real time. In conclusion, we show the clear color change on contact lens, and we check the clear color change through the cell phone camera video, and we demonstrated Morse code pattern. And using the computer vision, we detect the color change, place, and amount. I would like to thank Professor Lee for supervising me during PhD, and also to my group members for their support. And also I would like to thank to KOFST and KSE ASG for this conference. Thank you for listening.